I guess I'll introduce you to Gaia, who's just going to give you a breakdown of Made. Thanks, Gaia.
Hello, everyone. Can you hear me okay? Cool. So I introduce myself. Obviously, name is Gaia. I'm a front-end team lead here at Made.com, and I'm just going to give you a bit of background on what Made.com is. I guess if you've come by Tube, you might have seen some of our posters everywhere. We sell furniture. How does a furniture business get to do a DevOps meetup? So let's look at that. I'm going to give you a bit of history on how Made.com came to today. It started in 2010. It was a very small startup. They had an agency, they outsourced to an agency an integration of a Magento e-commerce system and an ERP stock management system. And they had a website, and they wanted it to be pretty. But there was no tech team. There was a CTO, and that's when I came in. So at that time, I was as junior as it gets. I just about knew CSS and HTML, not even JavaScript. There was no team, so there were no code reviews. Everything was absolutely manual. We didn't even have Git. We used Tortoise SVN. I don't know if anybody has had any history with that. So we also, in terms of infrastructure, it was dedicated servers. There was no cloud, nothing, and deployments were manual and utterly terrifying every single time. It would, there was nervousness before and after, just waiting for the thing to crash. So at that time, in 2010, Made was a furniture business that just happened to have a pretty website. Fast forward to 2013, we now had a small in-house team that took care of Magento, so the front office and ERP. We still had the deployment of ERP organized by an external agency. At some point, we terminated that contract, and I just want to look a little bit at how we did things with ERP. And there was no handover, and we found ourselves having to do ERP deployments only out of hours, and the way that it would happen would be a manual SSH into a server, pull the code, restart, and just pray that things won't break. We didn't have any reproducibility of environments, so more often than not, there might be package dependencies that were missing in the production server that we couldn't know about because everything was okay in test. So at this point, in 2013, Made.com was a furniture business with a pretty website and a small tech team. So we fast forward again a couple of years, 2015, we had a new CTO joining, we had an architect and a few more in the ops team, and together with the development teams, they started adding some new tech. We, most importantly, started using Docker. So if we look at ERP again, we now had the ability to install ERP from scratch reliably and in a controlled way. We started having reproducible environments, and we started using infrastructure as code. So we go from there to 2019. We now have a loosely coupled, event-driven services infrastructure. This is both in the back office and in the front office. In the front office, for example, in the past year, we created a new GraphQL endpoint that serves data from a lot of our services, product data, and this is served to many different front ends. We now have an in-house mobile iOS application written in React Native. Our catalog browsing is in React, so we are adding a lot of new technologies everywhere. Our tech team is now about 100 people strong. So we went from a company that in 2010 was a furniture business that had a pretty website, to what we think of it as a tech company that just happens to sell furniture. And please, if you can put your hands together now for Roman, who's going to talk about orchestrations and why is it important to make fast deployments. Thank you.
Thank you. Hi. All right. So, hi everyone. My name is Roman. I'll be talking about how we tackle the orchestration problem here at Made. And why is that important. So this is my second talk, so please forgive me if I get worried and start talking too fast. So first, a bit about me. Python developer here at Made for almost, but not quite 2 years. Originally, I'm from Latvia, so obviously I came here to steal jobs and not work at the same time. Hey. On most social media platforms, you can find me at Roman Tomjak. So back to the talk. So what is orchestration? So orchestration is automated configuration, coordination, and management of servers and services. But why should you care? Well, first of all, it saves time and money. But there are other benefits to that, such as automating repetitive and manual workflows, which dramatically improves productivity, reduces errors, speeds up operations, and ultimately empowers users, i.e. me, to serve many of my IT needs. So a couple of years ago here at Made, we had long feedback cycles where deployments were quite complex, and they sometimes could take even up to like half an hour because they were quite involved. Developers would pair with ops and would later own the box on which the service is running, and that was quite unproductive due to the long feedback cycle, and also for ops when they need to do some work on the box itself. But we obviously have the service running on top of it, so we're sort of like stepping on each other's toes. And each service would own, each service would run on a dedicated EC2 box in multiple availability zones. So that also cuts into high operational costs because we have like a lot of boxes. One other thing that I want to mention is we also had unstable deployments, but I'll touch on that a bit later. So where did we go from that? Well, deployments are now less than 60 seconds. But of course, CI takes some time, tests take some time. I know I should have added an asterisk to my talk. But yeah, so now we have a short mean time to change, which allows us to quickly react to feedback or incidents. And last year, this was really important because we have a service that tracks of how much stock we have and how much we can sell. And one of the problems was that for some reason, not developers' fault, it was raising exponentially events. So like each event would raise even more events and so on and so forth. And that was actually, that was a big problem because that would mean we would sell a lot more stuff that we don't actually have. We did some investigation and we identified that if we do not intervene, it will take around like 1.5 years to catch up to all the events because it was like event-driven. So we fixed it. Well, we identified, fixed it, and deployed to prod in altogether in like less than an hour, which is amazing that we can do that. And yeah. So also one of the things is that we also optimized placement onto servers, which maximizes resource usage and increases density and also reduces costs. And also teams are a lot more independent now. The developers, we don't even notice when ops are working on some underlying layer beneath the services, a couple layers down our stack, which is also great. So now Both teams can work independently, which is great. So of course we had to solve a lot of problems to get to this point, and this is George. He's going to help me to guide through all of these problems. So he's new, and he's going to be building an app here at Made. And we hopefully go through all of these topics, which sort of like generally fall into like one of the three groups. It's either configuration, coordination, or management. And at the end of it, if I have enough time, which I probably will because I'm going to be talking really fast, I'll do like a live demo. So yeah, let me start by saying this. So software development is hard. Infrastructure gets removed, updated, or extended. Configuration changes, software crashes, software gets redeployed, deployment fails, needs a rollback. Placement, scaling, rollouts, environment-specific configuration, sensitive configuration, which should not be committed to your source control. Well, should not be source controlled. And also how services talk to each other and yada yada. It's a lot of talk. It's a lot of stuff that we need to take care of. So, before DevOps, developers would write the code, pass it on to QA, and let the operations team run it. There was no cloud. Infrastructure never changed. Service discovery was not a thing. Code was the only thing that sort of developers would need to worry about. Now that's slightly changed. Because newsflash, it is my problem now. Like I need to take care of how services find each other and things like that. So this is sort of like all the things we now need to take care of in our day-to-day work. And so me, the developer in me screams like, oh my God, I just want to write a service. I just want to write some code and solve a real-life problem, which is fine, and it's fair. I wish I could just write in any language and run everywhere in exactly the same way, so that it's also optimally deployed and managed by someone. There are no machines. All resources are ultimately provisioned and on demand. But it doesn't stop there. It also depends on the type of deployment. Front end, back end, big data, full stack, DevOps. Each has different frameworks and stacks, and they often don't communicate well with each other. And also, as more and more companies adopt cloud technology, the desire to run and operate cloud applications increases. But how do we make it talk to each other, work together in cloud? So that's where orchestration comes in. And I'm not talking about this. I'm actually talking about this, and more specifically, container orchestration. So containers, I don't know, you probably know what containers are. There's like lightweight to virtualize applications. Google has been using containers for more than 12 years. Kubernetes, which is like at the bottom right, is a solution by Google to manage containers and container clusters, redundancy, resilience, things like that. But obviously, container orchestration is not enough. We still have to take care about configuration, provisioning infrastructure, secrets, things like that. So here, I'm going to be talking about that thing in the middle, which is called Nomad. And it's a workload orchestrator built by a really cool company. So who's here heard of HashiCorp? Woo! Yes, of course, everyone has heard. So they provide like a suite of open source tools intended to support development and deployment of large-scale cloud applications. And each of their tools that they do, they focus on sort of like a small and focused thing. Step in the software deployment life cycle. Sorry for that. So they build tools like Vagrant, Packer, Surf, Consul, Nomad, Vault, and they are used by companies. All these tools are used by companies like BBC, Mozilla, Adobe, HP, big companies, DigitalOcean. So the tools that they do, they work on like sort of on all layers. And our stack is very similar to this. That's why I'm borrowing this super useful image from HashiCorp. We're not actually using Terraform, like at the end, at the bottom of it. We're using Ansible, but I'll go that in a bit. Then we also have the Vault for secrets management. On top of that, well, sort of besides it, runs Nomad, which is for workload orchestration. And the last bit is Consul, which takes care of networking, also configuration, dynamic configuration, and service discovery. So here in this talk, I'm going to pretend that we're building an app with George that I already introduced to you. And we'll sort of go through all of these layers and what do we, like how do we do that at Made? Yeah. So the first tool is Ansible. So we use Ansible for provisioning and configuration. Historically, at Made, we've had more experience with Ansible, so that's why we're not using Terraform. But the Terraform and Ansible, they can be used interchangeably. But what I like to think is they complement each other. So you can either provision infrastructure with Terraform and then use Ansible to do some configuration on that instance, or you can call Terraform from Ansible to do the infrastructure and then just do your provisioning on the resources that Terraform created. Before Ansible, we were using a thing called Puppet, which also has like an orchestration sort of tool collective. So this is the bit that I mentioned before. So if you want unpredictability in your deployment pipeline, that's what you want to add. By the way, is everyone familiar with Ansible, how it works? Okay, yeah. So basically, it's like an agentless provision, like an agentless tool. The way it works is you have some YAML files and some playbooks that map roles and tasks onto hosts. And that happens using like Python, so you don't need any sort of client running on the server. You just SSH into it and run tasks. We're now slowly moving away from Ansible. We're doing like a lot more stuff with Cloud Init, which is available on Amazon and all the cloud providers, all other cloud providers. So boxes bootstrap themselves, and they authenticate with Walt, then Consul template, some config files, and things like that. I'm going to be talking about Walt and how we use that a bit later. So one of the things, why is this important, why we're moving away from Ansible and onto Cloud Init, is because this has reduced massively our deployment time. So Magento, which is our e-commerce platform, went from like 5 to 10 minutes per box to under the minute in parallel. So now to spin up like 10 boxes, it takes around a minute rather than like an hour, which is very important for auto-scaling groups. And now when ops do releases in production, they just like kill a box and it just gets re-provisioned automatically. Yeah, so I think that's all about Ansible. We're all going to have Q&A, so maybe you can ask more questions. So we've dealt with sort of resource provisioning, but how do I deploy apps? Well, we create a playbook, and that deals with all the infrastructure for provisioning a service. So that's like things like RDS, S3 buckets, things like that. So, great. We've made George happy. He can tick one thing off his list. Next, we're back to this super useful image. So we dealt with sort of like the very basic, like the operations layer. Now we're onto security. Where do I store like my API keys, passwords, certificates, things like that? That's where Walt comes in. So you can store like sort of arbitrary key value secrets in there, API keys, passwords, SSL certificates. It also provides on-demand secrets like database credentials or AWS key pairs. We try to use this, but we basically run into issue where we run out of IAM users on AWS, so it didn't clean up properly after itself. So we're slightly like backpedaling on that, and instead, EC2 boxes, when they come up, they authenticate with Vault to get all the secrets that the box needs to configure itself. And there's also like some other bits that are very useful, which is like you can use it as a encryption as a service, where you ask it. So you can store encrypted data on unencrypted S3, for example. Yeah, that's about it. That's about all the secrets. It's super useful. That's another list. That's another item off the list. Back to this thing. Now we know where to keep our secrets. How do we get like the infrastructure where things should run? But now we need to know like where and how to run things. So that is where Nomad comes in. So Nomad is a tool to like manage like a cluster of machines and run apps on top of them. Users declare like what they want to run, and Nomad takes care of where and how to run these apps. At Made, we heavily used Consul. So at the time, we were planning to use Walt. So Nomad, which is also built by the same company, HashiCorp, just made sense to try it out. Not to mention, it was a lot simpler at the time than Kubernetes and Mesos. And Docker Swarm was like a mess. So Nomad is battle tested. It can schedule around like 1 million containers in under like 5 minutes. And it supports 3 types of jobs. Service, which are the long-running things. Batch, or for short-lived things. And also system, which runs on all the clients in the cluster, which is useful for things like monitoring or logging and things like that. Sidecar example from Kubernetes. So why is it great? Because it's simple, and it's also powerful at the same time. It hides all the complexity that you don't need, but at the same time, when you need that complexity, so for example, like rolling deploys, blue-green deployments, machine failures, everything is handled automatically by the Nomad. And so this is also one of the things why we've managed to save costs, because it uses a thing called bin packing, which optimally places services on top of boxes. So we no longer have like gazillion of boxes. We now have a few of them, and they are the services are spread out around them. Yeah, so Nomad is also used by big companies, other big companies like Circle CI and eBay and lots of others. Great! I can hear you all saying yes. We can run a thing. Back to this. Imagine we have like a monolith. So developers are obviously cool. They extracted email notifications from that monolith into a new service. And that service runs somewhere on Nomad and is, of course, dynamically configured. But now we have another problem. How do you find other services and configure all those loosely coupled services? That's where Consul comes in. So when applications moved to the cloud, it caused a shift from like static IPs into like dynamic service discovery. And Consul is a tool to solve just that problem. So it's dynamic configuration, feature flagging, coordination, health checks, which is super useful to route things away when things are not working well in the terms of service, because you can define a health check on the service, and if that fails, Consul just takes it out of the catalog. And there's like many other features that it provides. At Made, we use Consul a lot in tandem with a tool that is called Consul Template. That is a tool, it basically connects to the Consul cluster and observes the key that you specified. And if that changes, you can tell it to template a new file using the configuration from Consul. So that's really useful for things like HA proxy configuration, where when new boxes come up, they register themselves in Consul saying like, hey, I can provide the HTTP service. So the Consul template takes that and adds an IP address to the HA proxy and reloads it. So boxes and IP addresses get automatically added and removed from the HA proxy as they come up and go. We also use it for things like A/B testing, coordination, and configuration. It's really, really powerful tool. Yes. So for the last bit, which is the load balancing, I don't have that super useful image, so I'm not going to show it. But basically, we've gotten to a point where George has successfully deployed his app on our infrastructure, and it's looking great. And it got featured on Hacker News. So it's really popular. And what do we see when we visit? That. So it's time to scale it. But luckily, with all this infrastructure in place, it's very easy. We just add another tool, which is, this time, it's not built by HashiCorp. So Fabio is a tool, it's built by eBay folks. It can talk to the Consul cluster and picks up configuration directly from Consul, so you don't even need a config file for this. And you don't need to restart it like traditional HA proxy configuration tools. Yes. So I've been talking for like a couple of minutes now, and it's a lot to take in. So let's do a small recap. This is all the stuff that we covered: provisioning, the infrastructure that we need, how we store secrets, how we access them, things that where we run things, how these things find each other things, and how we can access those things from when you type something in your browser, how you access these things that run somewhere in the cluster. So let me help you with that. This is how we do it. So there's a small, imagine that's me. I'm running an Ansible playbook. That provisions me S3 bucket, creates an RDS database, maybe registers a domain. And then we also have the Nomad, which schedules a job to be executed. And the Nomad scheduler evaluates that job. So, at Made, that happens automatically, but you can also like configure and submit the job manually, which I'm going to show at the end of this presentation. So the Nomad scheduler evaluates the job and generates an allocation plan. So if you do it manually, you can see that where your service is going to be put, and if there's like enough resources for that. But our ops team is like too good with our resource planning, so we've never seen that problem. So after Bob has submitted his job to Nomad, it's been evaluated, and Nomad sees like, okay, I need to pull some secrets. And the way Nomad does it, it can provide them as an environment variable, which is like an API token or things like that. Or if you use certificates, it also creates like a special directory where it puts them. So your service always knows that, for example, in alloc/whatever, you can find your certificates and things like that. Also, because in this super file, I'm going to mention it, this is the Jobsback file. We've defined it. Okay, so we've also need some configuration from Consul. I've already covered. Consul is like a distributed key value storage alternative to etcd. So Nomad, of course, here helps us with that. Automatically, well, if I've configured, it automatically injects these environment variables from Consul into the service. And because we've also specified that we want to provide some services to other services, it also registers a service with the Consul catalog, which is how other services find other services. So at this point, nosy Fabio notices that a new service has popped up in the Consul catalog, and it has requested to be routed via a specific DNS record. So Fabio sets up that route and sets up that route so that it knows that if you type something in the browser, it's going to just redirect you to somewhere, to a service somewhere running somewhere in the cluster. Which is exactly what I said. Sorry. Yeah, so now when Alice types service.made.com, it actually goes to Fabio, and Fabio knows that, okay, so this service is running here on this box, or boxes, and it just routes the service automatically. And it uses like a round-robin algorithm for that, but you can also say that like 75% of requests should go to these 3 boxes and 25% to that. So that can be used for like experiments and things like that. So, Jobsback. This is the magic file. This is the single file that we need to configure all of that. Secrets, services, environment variables, resource needs, and Docker driver, and things like that. So it's actually quite simple. It uses the HCL, and it's very readable. So here you can see group. Groups are usually collocated, but they can be configured to say never put these services onto the same box, and that is configured with something called placement affinity stanza. This also, like in this file, in the Jobsback, you can define recovery strategies when, let's say, service exits with anything that's not 0. So Nomad restarts the job automatically. Or if, let's say, health check does not pass, it also reschedules it to run somewhere else. And you can configure many other options here. Like this is amazing. You have just one file and you can configure everything you need in there. It's great. So one thing we learned from this is that you should always define specific needs, specific resource needs, because Nomad uses that to decide where to put your things. So let's say if you say that, oh, I'm only going to use like 250 megahertz of the CPU, and you do that for all of your services, and then one service starts to use a lot of CPU, that is actually going to affect all the other services. So we had that problem where one service was consuming a lot of CPU, and what happened is that the Docker daemon actually became unresponsive. So what that did is we could not deploy any services because the Docker daemon was not responding. So always define correct resource usages. That's the lesson that we learned. Yes, I've been really talking way too fast, so now is it time for demo. Whew. Pray for Roman. Okay, so I've built a super small Docker file, which is going to run a Python app for me. This is the super file, the Jobsback file, where I've defined like, hey, please pull this image. This is going to pull from the public Docker hub. I'm going to add some labels, define the resources that it needs, and here I'm going to register a service which is gonna make this available to other services. And here, this is this super tiny thing. This is how Fabio actually picks up and says like, oh, okay, so everything that's incoming on FAF60 made-test.com, I'm gonna route to this service. And this is my Python file. It's super simple. So the way Nomad works with ports is if you define in the config, let's say I'm going to have an HTTP port here, named it. So Nomad is going to expose to me an environment variable saying Nomad port HTTP. So this is how the service knows on which port to listen, and Nomad just routes it to it. I'm going to now do some command line tricks. Okay, here we go. Of course. Okay, this is all right. I didn't have the Alpine image. That's fine. Okay, so normally this would be done by CI. This is me being a code monkey. Okay, so now that I pushed it, it's available on the publicly available on the Docker Hub. And now, normally, well, because I'm doing this manually, I'm going to show what Nomad actually responds when I tell it, like, please, can you run this somewhere? Okay, so Nomad told me, yeah, everything is all right. I'm going to create a new job. It's going to have one group, and there's going to be only one task running in it, which is going to be my web service. And so let's run this. Okay, cool. That worked. Yes. All right. Woo! Okay. So now I'm going to do a small trick. Oh no. Massive failure. I actually set it up already so that it runs 2 instances. Ah. So the trick was here. If I keep refreshing, you can see that Fabio is actually routing it to to different containers. Ah. Oh yeah. Oh yes. Maybe not 200. Okay, so now you see that instead of 2, Nomad is actually going to run 10 of those, and it tells me that, okay, I'm going to create 8 new, and 2 are going to be updated in place because 2 are already running. Okay, so you can see how easy it is to use Nomad. It tells you everything that it does and what it's going to do. It's almost, if you're familiar with HashiCorp tools, it's like Terraform when it does you, hey, I'm going to create this infrastructure, and with all these like settings. So now you can see, like, I didn't have to do anything. I just changed the number, and like it works. Yes. Thank you. Okay, so that worked. So in recap, what we've done is we've massively improved our deployment pipeline. Deployments are now quick and easy. In fact, anyone can do it. So like QAs can deploy stuff, developers can deploy stuff. Yeah, I don't know. Cleaner probably also can if he has credentials. So short mean time to change. This allows us to quickly react to incidents, which is amazing. So this is like one of the things why it is important to be able to deploy fast. Like I said, with that story that I told you about, that if we wouldn't intervene, it would take like 1 year to catch up with the events. And also, obviously, reduce costs, because now instead of all the services running on separate boxes, everything is sort of like compacted, and we still have availability zones, but each service does not need a box. And what is great about that we don't even see how any work done on the infrastructure layer impacts the services that are running on top of it. Because if ops would, for example, kill a box, well, not necessarily kill, but say that we're going to do some work on this box. So Nomad would automatically reschedule all those services to run on different boxes, and then ops can do the work. And the developers, we won't see any difference. And that makes, for the last point, which is the autonomous teams, that we can independently work on all of the layers of the service without stepping on each other's toes. That's it. That was me. Thank you.